Okay, so this is just the velocity versus time graph. All right, using the data that was given, we have, all right, our one book incline. These guys are here. That is being represented by the dots here that are filled in with a little bit of the darker. All right, they're the filled in dots, and the 2 book incline. All right, I'm plotting this along with this. This is the so this would be the coordinate. Now these ones I did with an open dot. You can see already that they are steeper, so it should indicate, all right, they're increasing their velocity at a much quicker rate, which agrees with our data. We just have to draw in a line of best fits for this. Let's say right about here. This looks good. That's pretty solid. Okay, so then what you guys are going to do, this is our 2 book, and this is 1 book here. Alright, so the lab asks us to calculate, all right, the slope from the lines of best fit. So for 1 book, we want to use the 2 data points, all right, that are the closest to the line, potentially on the line. So I'm kind of thinking, let me zoom in here, that this guy, see how it's just a slight bit above, this guy just a slight bit below. I think that would kind of wind up giving us a very good indication of the actual slope. So I would kind of highlight those 2 points and find their coordinates on that data table. So this was for the 1 book. All right, so it's my first time, and my last time it happens to be. So essentially, this is the first, all right, coordinate, and then this guy is my last coordinate. So when I'm doing the slope, when I'm calculating the slope of the books, or of this book, I'm sorry, of the card down the book, the 1 book. All right, you guys know the slope equation. It's y2 minus y1 over x2 minus x1. This one's obviously later in time, so it's our y2 and x2. So y2 is the 30.03 minus y1, 14.93. Divide that out by x2 minus x1. Okay, and this is going to be our slope. When you calculate this out, this is going to be your slope, and that would be in the unit of centimeters per second, which is going to be centimeters per second squared. Okay, so now the velocity for the second one. Okay, so here's our second book. I mean, you could go with a few different ones. You could probably, use this guy and this guy, or see this guy's slightly above, this guy's, slightly below. You could use these 2 points. You could use this guy and this one, or this one and that one. I think that would be fine. I'm going to just do, I'm going to do the middle and this guy down here. Okay, so 1 and 3 on that data table. So points 1 and 3. Zoom out, slide this over just a tad. So 1 and 3. So those are going to be what I'm plugging into my slope equation. So y2 minus y1 divided by x2 minus x1. When you calculate that out, it's going to be the same unit for the acceleration. And why, guys, is this acceleration again? Alright, because on a VT graph, the slope, alright, you're pretty much doing the y's here over, I gotta make sure we label this as time. Y divided by x, centimeters per second divided by seconds, is going to be centimeters per second squared. That is the unit for acceleration, and you can also just figure out you're increasing your velocity. Your velocity is increasing. We've now been working with this for a couple weeks here, so we should notice that, all right, when we have a positive slope like this on a VT graph, we can calculate the acceleration. All right, that, guys, is, it's a big thing. All right, that is, so you can see again the acceleration is definitely, it should make sense. So we can take a look at both graphs side by side. Let's see if this helps you guys out and makes sense of it a little bit. Right about there. So DT graphs, you can see that both, all right, are accelerating with that curve. Book 1, all right, gets to the same distance, gets to the same 100 centimeters, but it doesn't do so until about 3.3 seconds, where the 2-book incline, all right, the object gets there in approximately 1.7, around there, or a little bit past maybe 1.7. So this guy is reaching, all right, that distance faster. All right, you can see that he's accelerating at a faster rate. Over here, all right, you can tell the acceleration by the steepness of the slope. The steeper the slope, the greater the acceleration, which, all right, should match up and kind of with what our other graph says.